Greetings, chemistry students. We're going to do an activity in class that requires you to use an infographic that is included in the website Understanding Global Change. So this is a presentation that I found on the website, and I'm just going to read through how you are supposed to use this entire site. Some of this should be review for you. All right, let's go. So when you go outside, I want you to think about what you notice. Do you notice the smell of the air? Do you feel the warmth of the sun? Do you notice the birds, the blue sky? Do you see people in the streets, or are they driving their cars? Remember that many of the processes that determine how the world looks today have been happening for millions of years throughout the history of our planet. And recently, especially in the last 200 years, humans have caused many changes to Earth's climate and ecosystems. So to understand these changes, let's take a closer look at the parts of the Earth and how they interact to shape the world around us. So this is a simplified view of the infographic that we're going to be using. So let me explain the parts of this to you. So at the website, the team of scientists and educators developed a way to organize the major components of the Earth system. Within their framework, they have three primary categories. They have the red ring, which is the causes of global change. These are the human activities and the non-human phenomena that change the Earth system. The yellow ring is how the Earth system works, the major processes that shape the world around us. And then finally, the blue middle are the measurable changes in the Earth system. So this includes the evidence or the data that indicate how fast and how much the world is changing. So the Earth system is going to consist of four major parts: the atmosphere, hydrosphere, geosphere, and biosphere. So we're going to start by just briefly reviewing what each of those are. So first, let's look at the atmosphere. That's the layer of air around the Earth. It includes the air we breathe and the clouds that bring us rain. So those are all part of the atmosphere. And so remember that wind is also a part of this too, because that's just simply the movement of air. And so in this diagram now, you've got the sky that's highlighted while everything else is kind of darkened out. Our next sphere is the hydrosphere. This includes the parts of the Earth that have water in the form of ice, liquid, and gas. Earth's oceans, rivers, lakes, and the water that we drink are all a part of the hydrosphere. Next, we have the geosphere, which includes all the land on continents and under the oceans, and also the rocks, both solid and liquid beneath our feet. Yes, liquid rock. Remember, that's what magma is. So you can see that this volcano, out here is highlighted as well. And so is the mountain, because all of these earth forms are going to be a part of our geosphere. And then the last part is the biosphere, which is all living things, including humans. Living organisms affect and are affected by the atmosphere, hydrosphere, and the geosphere. And later on, you're going to see that humans and living things are going to also affect these spheres as well. So what you may have noticed here is that the Earth is a system of connected processes in the atmosphere, hydrosphere, geosphere, and biosphere that shape our world and how it changes through time. We begin our exploration of global change with the Earth system of connected processes. In the following slides, we will add system processes to this diagram, which we hope will help you think about the cause and effect relationships among the parts of Earth's system. So to understand how the Earth works, we first need to know about the sources of energy for processes in the atmosphere, hydrosphere, geosphere, and biosphere. For understanding global change, the most important components of the Earth's energy budget are how much sunlight is absorbed and reflected and how much heat is re-radiated. These primarily affect the atmosphere, hydrosphere, and biosphere. Additionally, Earth's internal heat drives processes in the geosphere, but contributes very little energy to Earth's climate and most ecosystems. Most of these 4 energy budget phenomena are represented as icons in the diagram below. So when we go to the website, you'll be able to click on these icons, and then a new page will pop up, and then you'll be able to do a little bit of research there. And I just wanted to remind you that the heat that is coming from Earth's internal engine, that is generated through the radioactive decay of certain elements that are in the Earth's core. Thus, the sun provides the Earth with most of its energy. Today, about 71% of the sunlight that reaches the Earth is absorbed, and the rest is reflected back into space. So here you can see that you've got incoming sunlight. It's high energy. You can see that the wave lengths are very small, but then as that's re-radiated, it is leaving Earth as long wave infrared radiation. So incoming is short wave, high energy. Outgoing is long wave and low energy. So sunlight and re-radiated heat are the energy sources that drive the processes in the atmosphere, hydrosphere, and biosphere. However, because the Earth is a sphere, more sunlight is absorbed per square area in the tropics than at the poles. Thus, it is heated unevenly, and this is why it is warmer near the equator than at the poles. And that's what we studied in our sunlight angles activity, where I was shining the flashlight on the whiteboard, or where you guys shined it onto graph paper, and you saw that the lower the angle that the flashlight was on, the greater the area of the paper or the whiteboard that was illuminated. And the more area that's illuminated, the weaker the intensity of that solar energy is. So that's why we have higher temperatures at the equator, because the sunlight is going to strike the equator more directly. And notice that it's got a smaller amount of area that is being reached by that sunlight. So it's very intense there. Whereas at the poles, like at the South Pole here, we have a lower angle and we have a greater area. Remember, like, the amount of energy that the sun puts out isn't changing, but as you spread it out, it thins, and it's not as intense as it is here at the equator. Earth's internal heat is left over from when our planet formed and from radioactive decay of elements inside the Earth. While the Earth's internal heat contributes very little energy directly to the processes that shape Earth's climate, it is the energy source that drives processes like plate tectonics and parts of the rock cycle. And so here in this little pie slice, you can see that the core is a lot hotter than the areas that are closer to the surface. The global energy budget powers the fundamental processes that shape the world around us. To explain how the atmosphere and hydrosphere work, it is important to understand these 4 processes: the greenhouse effect, atmospheric circulation, ocean circulation, and the water cycle. Each of these processes will now be explained briefly. And once again, these icons are here, and when we get to the website, you'll be able to click on them and read more about it. All right, this is a really nice graphic of the greenhouse effect. So here's your high energy sunlight coming in, and notice that as it comes in, our greenhouse gases, carbon dioxide, which has the black and the red, and methane has the black atom in the center with the 4 hydrogen atoms around the outside. And notice that as the sunlight comes in, they are not affected. So they are transparent to this short wave high energy coming in. But then as the short wave energy is radiated by Earth's surface as long wave infrared energy, notice that the molecules here, the greenhouse gases, are now highlighted. And you can see that the infrared energy is going to come up. It's going to affect these molecules. And then the molecules are going to bounce these red arrows back down towards the Earth. Some of it will escape, but a lot of it is going to be re-radiated back down to the earth. And that's what causes the warming of the earth. This is the process that's called the greenhouse effect. So our greenhouse gases redirecting infrared radiation back to the surface of the earth, that is the greenhouse effect. And this is the process that keeps our earth livable and warm. Without it, we'd be much colder and all surface water would freeze. However, we have to keep in mind that increasing the amount of greenhouse gases in the atmosphere also increases Earth's average temperature, which affects global climate and ecosystems. Atmospheric and ocean circulation influence each other. These processes are driven by the uneven heating of the Earth's surface by the sun and by Earth's rotation. Atmospheric and ocean circulation are the two primary ways that heat is redistributed across the entire surface of the Earth, which in turn brings us our daily weather and shapes regional climates. Increasing the Earth's average temperature, for example, due to an increase in greenhouse gases, changes atmospheric and ocean circulation patterns, altering climate and in turn Earth's ecosystems. And that's a really important thing. So the hydrosphere is going to help to distribute heat around the Earth because there are convection currents that are happening within our oceans. And you can see in the picture, like the red arrows are showing you where heated water is traveling and also where cooler water is moving as well. And then also remember that our atmosphere, the wind, is going to push air around the globe. What's the connection between these two? Well, the temperature, or like the heat from the water, is going to affect the temperature of the air above those areas. So the air above warm water currents is going to be warmer, and then it gets pushed around the earth, while the air above cooler waters is going to have a lower temperature. All right, you should recognize a lot of the words that we have on this slide. This is the water cycle, the movement of water through the Earth system. It's going to shape the land, atmosphere, and biosphere. It's important because water is essential for all living organisms. It transports heat and itself is a greenhouse gas. So like our three main greenhouse gases are water vapor, methane, which is CH4, and carbon dioxide, which is CO2. So now that we summarize the key processes in the atmosphere and hydrosphere, we're going to turn to the fundamental processes in the biosphere and the geosphere. And in the next two slides, I'll explain these processes. And once again, here's a portion of that infographic. And once you get to the website, you'll be able to click on these and read more about them. Okay. Plate tectonic processes and the rock cycle, which includes weathering, shape Earth's surface. Continents and oceans form and change over millions of years, influencing how ocean currents and air move and how water cycles. Over millions of years, burial of carbon from living things and from the weathering of the Earth's surface influence the amount of carbon dioxide, a greenhouse gas, in the atmosphere. So we have a lot of different, I hope that you're realizing that we have a lot of different sources of carbon dioxide that are actually moving into our atmosphere. Evolution and species interactions. And so again, like now that we're talking about species and living things, we're moving into the biosphere. They profoundly affect the Earth system. For example, the evolution of photosynthesis dramatically increased oxygen levels in the atmosphere. Life has and continues to be shaped by evolutionary processes. Evolution is the changing characteristics of populations of organisms over time that are passed or inherited from one generation to the next. Additionally, all species are affected by interactions with other living things, and these interactions influence the abundance, life cycles, and evolution of organisms. For example, in coral reefs, species compete for limited space, and various fish, starfish, and snails live in and feed on coral and algae. Fundamental to how the Earth works is the cycling of elements such as carbon, nitrogen, and phosphorus through the four spheres. For example, carbon in the form of carbon dioxide is captured from the atmosphere by photosynthesizing plants and is released back to the atmosphere through processes such as respiration, decay, and from the burning of fossil fuels. And so just remember that animals eat plants, and then the carbon from the carbon dioxide that the plant absorbed becomes a part of that animal. And then when the animal dies, the carbon that contributed to the structure of the body is now going to enter the geosphere into the soil. Also, when we cut down trees and plants, like those stems, the roots, the trunks, the stumps that are left, all of that starts to decay, and carbon dioxide is released into the atmosphere throughout those processes as well. Elements cycle through the Earth system through various human and non-human processes. This diagram shows some parts of the carbon cycle, including some of the ways carbon dioxide moves among the four spheres. Human activities, such as the burning of fossil fuels from geologic reserves, deforestation, and agriculture, contribute carbon dioxide to the atmosphere. Carbon dioxide is also absorbed in a variety of ways, including by the ocean and photosynthesizing plants. However, these sinks, or these reservoirs, do not remove all of the carbon dioxide released by human activities into the atmosphere. So we have an imbalance. So we have these storage places for carbon, but we humans are removing carbon from those storage areas and putting it into the atmosphere. And that's what's causing this global change. So the amount of carbon dioxide in the atmosphere, and again, remember, that is a greenhouse gas, a GHG, and it continues to grow, raising average global temperatures. A major focus in the study of global change is explaining how climate and ecosystems change. Given the number of factors that influence climate and ecosystems, including all of the processes outlined in the previous slides, we have placed the terms climate and ecosystems in the innermost ring of how the Earth system works. So again, this is just a little snapshot of what that part of the infographic is going to look like. So this is just a small piece of the puzzle. A region's climate is defined by its average weather, including its seasonal variation in temperature, precipitation, wind, and clouds over long periods of time, meaning decades, centuries, millennia. So climate is long-term. Weather describes the short-term variation over hours or days or weeks. So like on your app on your phone, you're looking at the weather. That is not the climate. The climate is like the average of all weather that happens over a long period of time. So on this map, they're showing you average annual precipitation, which is an important component of regional climates. In turn, annual precipitation is determined by the amount of sunlight received at different latitudes, as well as atmospheric and ocean circulation patterns. All right, we're going to skip through this slide and move on to the end. So you have now been introduced to the processes that are essential to how the Earth system works. To understand the causes of global change, in part 2, which is a different objective, we will turn our attention to the non-human causes and human activities that influence the Earth system. And we will then explore how we can measure the Earth system to determine how fast and how much the Earth is changing. Thanks for watching. Hopefully this helps you understand what this infographic actually means for our activity.